Booyah!
And here we go.
Nuclear chemistry.
Last chemistry
Unit of the year.
Can I get a woohoo?
Woo-woo. It's going to be sad.
For us, kind of. Yeah.
For us, yeah. Because now
we miss you already.
Now we just get to write the whole curriculum again and make it better for next year. So our first lecture is on our targets, essential questions.
Yeah, what's going on with nuclear chemistry? How does this business work? We're going to ask some questions and not answer them.
Exactly.
Like the first one.
What is radioactivity?
Again, one of those words that we've all heard of before we hit Regents Chemistry, where Monaco and I will maybe redefine
what it is,
bit.
Or clarify,
or go a little deeper.
Yeah. Is radioactivity useful? I thought, isn't it just dangerous? I know that, but is it actually useful?
We will find out.
How does a radioactive element decay?
Hopefully, there'll be some reference tables for that.
Oh, definitely.
And can I predict what radioactive isotope will produce when it decays? Ooh, another good one.
Yeah. Predicting products. Love it.
Like that.
Can you predict when a radioactive isotope will decay?
Ooh, I answered that today in my bell work. Hey! My turn. What radioactive isotopes are important to our daily lives? Real world applications.
All of them. No,
Well,
I did not answer the question.
Yeah,
That was a joke answer.
Carbon-14 doesn't do anything in my day-to-day life.
What type of radiation is most harmful?
Oh, there's a few different kinds of radiation.
Yep.
One of them is the boogeyman.
Yeah, totally.
How that? What are the pros and cons of nuclear radioactivity and or nuclear power?
And fission and fusion reactions. Like, there's got to be some good and some bad. What are they?
Nope, what isn't? And then what we will be able to do when we are done with this unit. First thing and foremost,
I can identify mass, charge, and penetrating power of radioactive emissions. Very important.
Yes, and the mass and the charge is not going to be hard because in the reference table, it's going to give you those clues.
And it goes back to reading your periodic table, atomic mass, atomic number kind of stuff. So it's really cycled back around to the beginning again.
Yeah, that's what's nice about doing nuclear labs is we will actually be able to review a little bit about atomic structure as we go back into the nucleus, and that'll help bridge us and get us right into review for the finals. So I can balance natural and artificial transmutations of nuclei to predict the missing radioisotope. I mean, right off the bat, there's 3 or 4 big
important
words.
Oh, yeah.
And like I told my class today, the bulk of this unit is a bunch of weird words and then half-lives.
Yeah.
If you can do that, then we're done.
Seen before. So,
and you've done half-lives.
Let's keep on with the ICANNs. Using table N, that's a specific Russian table, to figure out our decay modes and the half-lives of certain radioisotopes.
Yeah, they're listed and
right there for us to read and understand. You got to know what the heck this notation means.
That's it.
But once you understand it, it's like, whoa, duh.
Predict the mass and fraction remaining, time elapsed, and number of half-lives passed for radioisotopes. We're going to teach you the chart method to figuring it out. And once you got one little piece, you can fill out all the rest of the chart, and then you can tell us all of this.
Yeah, so there's 2 methods. The graph method, which you may have done in your living earth science classes, and we'll show you some pictures of these graphs. But this chart method that Milks and I have created or developed or used is like fail-safe. Will tell you all these things every single time. So hopefully you can see how that works.
Sure. And the chart method is in the lab, actually.
Yeah, good.
Yeah, chart method is in the lab.
I got to print that out.
Yeah, I can find the half-life of radioisotopes using radioactive half-life and experimental data. So I can go from actual numbers
to figuring out the half-life.
Yeah, not a big deal.
Cool deal. Okay. What else can we do? Oh, we can look at our unit syllabus and say, wow, it's kind of smaller than usual.
Yeah, when kids picked up the packet yesterday, they're like, this is the thinnest packet yet. And I said, you can say thank you now.
You're welcome. You're welcome.
Yeah, let's get on with this.
Remember, this is meant as a list, sequential order of operations. Do them in order, and you won't find yourself behind the ball.
No, and again, if we haven't figured that out yet, working ahead, I have some poster child children that are really starting to turn the corner on that. They're working ahead in the packet.
Yep.
Things are making sense in class, and all of a sudden their grades have gone like that.
Exactly.
So just saying,
use the syllabus, stay on task, stay on time, and you will have plenty of time to prepare for the Regents.
yeah, let's be done.
And that's all, folks. I push the button, I make it stop, I push the button.